Good morning, guys. Okay, just give me a few seconds. Okay, so good morning once again. This is our learning session for the Azure security track. For a number of us that joined us in the last track, where we went through Azure administration, basically looking at the fundamentals and management of Azure, the whole ecosystem generally. We had said the next would be talking about Azure security, but unfortunately it couldn't happen. That was last year, and but we are glad, yeah, it's coming. So for those who may be joining us just the first time, I go by Raji. That's my name. Uh, I do cloud, majorly Microsoft technologies, which I've been doing for a while now. Yep. So that's enough about me. So I want to believe that a number of us here would have gone through the last series of lesson we took for Azure administration, basically, because this is meant to build on the knowledge or probably skills developed out of that module, or better still, maybe in our current job role, we may have been working with Azure, which is actually a good place to start. So the way this builds is you already know Azure fundamentals, you know how to get your way around Azure, you know about the major of the core services. Azure has over 200 cloud services. You are not expected to know all, since they are grouped into specific use cases, but at the minimum, the basic services, compute, networking, storage, stuff like that, I believe we already know. So without wasting much of our time, I will just quickly run through how this would work. Just give me a few seconds. Let me bring up screen. Let's see. Okay. So we already know the essence of this course is just of this session is just to uh, guide us or probably help us pick up some of those fundamental skills around cloud and cloud security, just like we had done for the first session. Uh, it's a self-paced learning session, which means outside what we may discuss within this session, you're expected to do some kind of deeper dive to take a number of scenario-based lab uh, activities in order to drive home some of those skills and understanding. And if this is what you currently do as part of your daily job activity, it helps a lot because as you learn, you tend to enforce that with your activities or probably tasks in your workplace. And if not, it's always good that you get your hands on maybe the Azure free subscription. And if you have some coin, you can still just pay for some of those services that you may not have enough time to explore within Azure and get your hands dirty with a number of these activities. That is what drives home the skill, the understanding, and get you ready for any kind of opportunity that may come around this space. So we are committing to 2 hours every Saturday. It's typically just 2 hours. We may not do up to 2 hours depending on how much time we have to cover the lesson. But what I'd observed in the last session we ran was that average is between 1.5 hours to 2 hours. Then also we have a Discord channel. The essence of that particular channel too is to drive peer learning such that we are able to push ourselves into doing something, not just joining the session. There's always this um, cycle, which including myself and a lot more that people get into, where you do a lot of learning, joining session, watching videos, listening to podcasts and stuff like that. But we just keep that circle. We don't get to drive home those lessons, those knowledge by getting involved ourselves. And one way we can get involved ourselves is if we're in community of other learners. When learner A is saying, "Oh, I've been able to achieve this," that may kind of push you into doing the same thing. That's the essence of just being part of a community where we have people with similar objective. When they are doing what they do, you may also be encouraged to do the same thing, and that helps your learning. Then you typically need access to an Azure subscription. You could sign up for the free trial that gives you $200, and you have access to a host of uh, services for free. For a large number of activities or private services we'll be exploring for these lessons, they are part of the free trial that you can get. So you don't have anything to worry about. Then, if there's a need for us, because we'll make a reference to a number of stuff that we learned during this first activity, if there's a need for us to go back to it, we can always access them here. But that's still even just at random Google some of those Microsoft documentation that speaks to some of those services to help you uh, refreshing your understanding. Uh, we hope to run this for 8 weeks, starting from today, and we hope to complete the whole activities we have lined out here. Now, the objective of this is just to give us an understanding of security. Uh, Most times, the guys who are in charge of administration of services, this doesn't just apply to cloud, it applies to every other part of IT operations. The guys who are in charge of administrations, setting up configurations, typically don't give security consideration. What they're after is it working? If it is working, I move on. As long as there are no issues. Even though most vendors these days would include some basic security controls into some of their services, some of their products, such that if you do it this way, you should be able to do this so that you'd maintain some level of security. And in some cases, you have some baseline security that comes by default. But these controls, features, uh, most times are not enough to for you to maintain that desired security posture. Even though it is what to note that there's no perfect or private secured system anywhere, no matter how much you do, it doesn't mean that you are not exposed or probably that you are not vulnerable. It just means that you are doing as much as you can to keep yourself secured or probably make it difficult for any intruder to come and mess up your environment. So, want to develop that understanding, build some skills around implement security features, which typically not by default. You'd have to go and set them up. We need to understand how they work, what is needed, prerequisites in cases where we need to pay, and how they work well with some of those services that we have within Azure. They want to be able to maintain a secured posture for our organization or probably our cloud tenant, as the case may be. And a number of us may be working towards achieving some cloud security certification like the AZ500, which typically speaks to Azure security. That's the standard Microsoft certification for Azure security. You also have the 500 for the Microsoft Cloud series. You also have that also, but that speaks more into securing the Microsoft software as a service platform that speaks to M365 and the likes. Even though a number of some of those controls overlap, that is because the Microsoft Cloud is an ecosystem of what you have within M365 and what you have within Azure, and they are kind of they kind of overlap. Services you use in your daily activities within Azure, you typically use them also when you manage M365. If we have got time and we may typically also just run a lesson on the MS500 as well for those of us that work with managing the M365 ecosystem. Then also this would also help a lot if you are aiming at a more higher certification like the Certified Cloud Security Professional, which is a certification from ISC squared. What would expect to know? Some basic skills with managing Azure, some fundamentals of network securities and systems would also help. So, like I said, this would run for 8 weeks. Today, would just look at the basics of what it is for, or what does it look like with securing the cloud, putting Azure as the focus area. We'll talk about the first in-depth zero trust, shared responsibility. We'll look at the Microsoft recommended network architecture because the baseline, the reason why we'll be looking at this is that the baseline of, even though you are able to consume a number of services within any cloud platform, be it Azure, AWS, or probably Google, without you having setting up a network. But in an instance where you say that your data center or probably your IT presence is within the cloud, just like every the baseline for every IT presence, even off premise, is a network. You'd have to have that network as the baseline for you to bring together all your services, systems, applications, and stuff like that. So Microsoft has got a recommended network architecture. Not like you can't adopt any other architecture, but this is just the recommended architecture, and we'll see the reason why it is. So we'll look at that. Then in the second week, we'll look at the second most important factor when it comes to not just cloud, just any environment, any IT ecosystem, and that is identity access management. We'll talk about protection and governance. We'll be looking at identity protection, privilege identity management. We'll look at the hierarchy system within Azure policy. Then we'll now talk about network security. So this is looking at, so like I said, there are over 200 services within Azure, over 200. But when it comes to securing any cloud environment, it's always important to have a focus into what forms the core services or forms the baseline. And when you are able to implement majority of the security controls within this space, then you've done significantly enough to say that you've implemented a standard security baseline, or probably you've maintained the standard security posture. While some other services would come with their own peculiar security controls or probably best practices, but if you've been able to cover some of these focus areas. So these lessons are actually broken down into those focus areas. Where we talk about network and security, we talk about host and container. You could also refer to your host as your compute. We talk about your data. We talk about now security operations, which is a very interesting area. Then in the last class, we'll just run through some revisions and probably look at some case studies to drive home a number of these concepts we would have talked about. So that is that. So if you have got questions, you can always drop them there, and I can always check them and take them. So now let's now get started. So Azure security. Now, first, it's important to look at what security is before we begin to talk about Azure security. For a number of us, we'll be familiar with this, what is called CIA, and it's always very it's a very common concept that you see when information security is being discussed, and the really reason being that it kind of encompasses all what you talk about security, or probably the objective of security. So why am I doing this? Why should I do that? When we ask a layman what security is, you typically hear, yeah, I don't want someone to access my resources, which is just one bit of what security entails. But the CIA concept kind of explains it all in whatever dimension you may want to look at it. And CIA typically means confidentiality, integrity, and availability. So if I want a secure system, first primary, which is the most common, I would say yes, I don't want intruders to have access to data, information, resources. Yes, so I say I want to maintain confidentiality of that particular system, or probably that particular data, or that particular service. And that's what confidentiality is talking about here, ensuring that information is only accessible to those who are authorized to have access to them. Then you talk about integrity. So in some instances, you want people to access systems, you want them to access data, you want them to access resources, but you don't want them to just begin to manipulate and change them at will, or probably do with them things you wouldn't expect, or probably you wouldn't want them to do. So that means they are actually toiling, or probably they are interfering with the integrity of that particular system. And that's where integrity comes in. That is safeguarding the accuracy or completeness of a system. So if I want you to have access to this system, but I don't want to be able to do A, B, C, and D. But if you go ahead to be able to do A, B, C, and D by whatever means, then that means you've actually compromised the integrity of that particular system. It's just like you having a mobile phone, being an Android phone or probably an iOS phone, and you be told not to jailbreak it or probably not to root it. If you try to do that, then you compromise the integrity of that particular system. Then the next is availability. Uh, the essence of you making data or private information systems or putting them up is that you want people to be able to access it, you want to be able to use it. But in a situation where that ability to use it is now compromised, then that means the purpose of it is defeated. So it's actually considered a concept of security also, that the security of a system is breached if it is made unavailable, or probably it is made or unaccessible, or probably the level of service is degraded, and that's where availability comes in. So you want to ensure that authorized users have access to that information system when they require to use it. So you want to do stuff to maintain that. So the idea about security is you are without doing putting controls in place to maintain these three concepts, or probably putting controls in place to ensure that intruders cannot compromise any of these particular concepts. So that's the idea behind security. And when it now comes to the cloud as well, the same remains either or within a physical uh, IT environment or probably within a cloud. The same level of probably expectation or your objectives within a physical IT space still applies within the cloud, except that the strategy will typically change because in that particular concept or probably that particular situation, we are dealing with information systems which there are limits to how much you understand the back end or probably what happens behind the scene. So your focus changes to what is going to be your responsibility. And now that takes us to shared responsibility. This idea of shared responsibility, we discussed it in the last session, where we said when you are going to the cloud, typically when you are on prem, but when you manage your system yourself, you are looking at you owning almost everything. So you own your physical locations, you own your infrastructures, you own just think of it, you own almost everything. Yeah. But when you are now going to cloud, that changes. So before I come to this slide, so that you understand how this works. So now here, first, I believe we understand the cloud models: software as a service, platform as a service, infrastructure as a service. When you maintain an on-premise infrastructure, you are responsible for everything. And mind you, when we talk about security, the responsibility of security within the IT space also includes physical security. So, which means physical access to your information resources. So, at the basic, I'll be talking about maybe I have a data center where I have my core IT infrastructures. I'll be responsible for maintaining the security into that particular data center. Do we have physical controls who can get into the data center? Do you have cooling systems to maintain standard temperature so that that doesn't impact availability of service? Because the number of all these infrastructures actually heat up a lot, and when they maintain certain level of temperature, they go bad. So you want to maintain that level, which impacts your availability. So you want to maintain cooling. You want to maintain what else? Access, just basic access to that particular information. That room where you kept all those infrastructures. The next thing you want to begin to maintain patch level OS configuration on some of your core infrastructures, your servers, your network devices, your printers. just think of it, up to the last point, which is maintaining or probably managing security of users who use those information systems and the data or services they interact at that particular level. It's all your responsibility. And when you try to imagine how much resource you'd have to commit to doing that, which is where this comes back to. How much resource or probably resources you have to commit to do that. It's a lot, and which is one of the reasons why most organizations suffer attack these days. Reason being that in this part of the world, you are expected to be a generalist or probably a jack of all trades, like we all call it. We all call it. You are the database administrator, you are the system administrator, you are the network administrator. They also want you to be the security administrator, right? Because most organizations cannot afford to have separate team or probably separate individual managing that. So there's no way you can run that efficiently without gaps. And most of the time, the gaps actually come in the security aspect of things because they would expect that number one, organization may just consider that I'm not valuable enough. I don't have that thing that an intruder that would interest an intruder, so I may not be a target. Yeah, maybe yes, that may be true. Yes, or probably maybe or maybe not. You may not be the target, but most times an attacker may not the may not maintain a target. You may just end up being a victim of how do you call it? A victim of circumstance. That so the attacker is just doing his own stuff, and you end up being the victim in that situation, even if you are not the main target. So you within traditional system, you tend to commit a lot of resources. You'd want to do so many, but in some cases, you are meant to maintain certain level of responsibility, certified level of responsibility. Some you maintain partially, some you don't even meet them, and you typically don't care. And that's one of the areas where security comes in. But however, when you switch into the cloud model, you shift your responsibility, you shift your risks, you make a number of those risks or prime challenges, you make it the responsibility of someone else. Where since I would not be maintaining the physical location for my data center, I would not be buying hardwares and the stuff like that. The responsibility of maintaining the security of that, which also forms the baseline of my core IT, becomes that of someone else. And that of someone else, when you now look at the concept of aggregating resources, where if I need to maintain satisfactory level of security within my environment, probably I need to spend on security solutions. I need to spend on security resources. Maybe I need to, at a minimum, say get one security professional, spend on the security resources like a firewall, like a SIM, a this, a that, and when I look at that spend, just for me, maybe I am not that large. Another SME, small business of my size, would also need to spend almost the same. And when you look at these resources that we both are going to pay for or probably incur, it may typically be a resource that it's even enough to serve both of us. But because we are different environment, different organizations, we would not think of, oh, let's aggregate resources. But which is what you are getting within the cloud. That is why you may not be able to do or spend as much as a cloud service provider would spend on security or private security resources. So which means you are getting better value when you go with a cloud, and also the responsibility of or some of those risks you shift it to them. It becomes their headache to ensure that maintain patch level, their infrastructures are up to date, nobody gain access to their physical data centers and the like. Then also these cloud, in order to maintain competitive edge, they spend so much on the R&D and development. They evolve, and if you look at the rate at which the top service cloud service providers churn out cloud services, new features, spend on technology, it's massive. It's not what an individual organization may typically match any day, anytime. So you could see them leveraging cloud intelligence, artificial intelligence, machine learning, and the likes to improve uh, uh, their level of service, because they are doing that to give the best to their customer, and that places them at a better position to get more customers. But for you as an organization, you may just typically see it as this may not. Yeah, if you look at it, security actually hits your bottom line at the end of the day, but most organizations wouldn't look it at it that way, especially when they are not the tech, because they just see IT as an appendage somewhere within the business hierarchy, and they'll say, oh, you are just a cost center. But you can imagine when there's a breach, you need to pay fine, especially when you have a regulatory bodies this time around saying that if you are breached, you have to do this, you have to do that, you have to pay this, you have to pay that, or probably even if your property, intellectual property, is stolen or probably impact your goodwill, you see how much that will impact on your bottom line. So those are some of the advantages you get when you go with the cloud provider. They are able to do it better. So when you are going, depending on what model of service you are consuming, it still doesn't take away the responsibility of security. What it typically just means is that the provider knows its own responsibility and is meant to take it up squarely, while you also have your own responsibility, which you'd also have to take up. But if you don't know what is your responsibility, so typically there's this assumption that, oh, uh, it becomes the cloud provider's headache. It becomes a cloud provider. So the question is, what becomes a cloud provider's headache? So you need to know that not everything becomes a cloud provider's responsibility. So, for instance, when you're maintaining a software as a service, you are consuming a software as a service cloud service. A very good example of this is, let's say, your M365. Some of us that may be familiar with this, or probably you are consuming a consumer-based cloud storage, like let's say Google Drive, or probably OneDrive, or probably Amazon S3 Bucket. So, these are some of the software as a service kind of solutions. So the responsibility of the customer and that of the cloud provider uh, is maintained such that anything that has to do with your physical infrastructure up to the applications, your physical infrastructure up to the applications that manage or probably that offers that particular service, becomes the responsibility of the service provider. So let's take, for instance, if it is an email service like, let's say, Gmail Suite or Microsoft 365. Typically, if I need to set up that within my own environment, I have to have a room I call a server. I call a data center. I would have to maintain, no matter how small, my basic network infrastructures, my switches, my routers, my firewall, my internet or backbone. I'd have to have the Exchange server application installed somewhere. I would have to have a storage system somewhere for my mailboxes. I have to manage this. I have to manage the operating system on which the application I run the application. So I have to do this and maintain the security of that. But when I consuming a SaaS, if I'm consuming this as a SaaS solution with my service provider, all that responsibility becomes that of the service provider. What I'm only responsible for is access to that particular platform and how I interact with my data. Access to that platform, how I interact with my data. So, for instance, there was recently that was it last month? There was this vulnerability on Microsoft Outlook that impacts uh, Exchange server. So typically, when you log into your Microsoft Outlook, you have some authentication protocol running behind the scene, part of which is the NTLM version 2. So it was this vulnerability such that if someone sends you an email with an attachment, that attachment may be vulnerable and it takes advantage of a flaw within Outlook, and that impacts that particular protocol, and with that particular vulnerability, the attacker can maintain a remote access to the server, Exchange server, on which that mailbox is running. So now, for users who still run Exchange with Active Directory as an on-premise infrastructure, it becomes an issue because they need to fix that particular vulnerability. The attacker is able to do that because the vulnerability exists on the server or probably the application on which you are running that your infrastructure. So Microsoft will typically just go tell you about it, take time, come out with a fix and tell you to apply the fix. But for you consuming it as a software as a service of their Microsoft 365 platform, you have nothing to do. You just need to sit back and just listen to the news, except if it impacts you. So, but in that particular case, it impacts Microsoft. It's Microsoft's responsibility to do that. So even before Microsoft would typically come out to say this vulnerability exists, I believe this you can't quote me on this, but I believe that typically they would have fixed that if at all it exists within their cloud platform. They would have fixed that before they even come out, because a large number of time, even coming out to disclose vulnerability makes the vulnerability more popular, and that gives the attacker some kind of information that, oh, they can begin to look out for this and see if they can explore. So that's for software as a service. And the same thing applies for platform as a service. For platform as a service, it just means that you take on more responsibility. So managing some bit of the application, managing some bit of network configurations, managing a bit of the identity within that particular system, it becomes yours. You share it with the service provider, while the service provider maintains full responsibility for physical access, underlying operating system. And when it comes to infrastructure, in this particular case, the service provider maintains responsibility for managing anything that has to do with the physical part of your infrastructure, maybe the physical server, the data center, the cables, the cooling, and the lights. But anything out of that becomes your responsibility. You put up a virtual machine, which is a server, the OS becomes your responsibility, the application you run on it becomes your responsibility. You set up a network, the network becomes your responsibility. You install an application, the application becomes your responsibility. So, which means you are taking on more responsibility while the service provider is taking on less. So, which means that one of your primary focus area as a cloud security administrator would be for you to even understand where your responsibility lies. What is your responsibility with this particular service that you are consuming? And when you know what your responsibility is, you're able to now learn how can you take advantage of that and play your own part to maintain that level of security that you so desire. Now, within, like I said, there are about 200 cloud services within Azure, but you need to be able to identify what do you want to focus on primarily. Yeah, it's not like you wouldn't secure every other part, but you want to identify what are the core of any cloud service provider, and you focus on that as your primary level of defense. So, and when we begin to look at that, first, the primary and one of the most important is identity and access. How would you even access your cloud platform? How would your users access that particular platform? Cloud platform. And when it comes to the backbone of security, you'd always have this concept of the triple A authentication, authorization. Most times you add accounting or probably auditing in that particular case. So, which means that this speaks to the one of the first aspect of the CIA, which is confidentiality. For it to maintain confidentiality, then it means you must be able to match a subject and an object. So, which means I have this item. I want you to be able to access this. I don't want you to be able to access it. So, in context, you have to identify who is you. So, how to separate this you that should be able to access it from this you that shouldn't be able to access it. So, that's where you have the identity. Then, also, what level of access do you want, the U1 and the U2? to be able to maintain. So you want to focus on identity and access. This is what we'll be talking about. How would user authenticate, different means of authenticate, how to define level of access, either for resources, for users, probably for services, and the likes. Then also, next you want to talk about your networks, which is the backbone for your presence within the cloud. Also, what are the level of security controls you can always implement? This is your network. You could liken it to your perimeter network within your physical environment, which would be you looking at how do I maintain access to my network using firewalls, using access control lists, configuring my router, my switches, even though you won't be configuring routers and switches within the cloud, but there are a number of configurations, services that offers you similar feature that you could use to maintain how traffic flows into and out of your cloud services. Then next, you would want to talk about your storage because within the cloud, you are generating a lot of data. Those data are going somewhere. How do you maintain the management of this data or perhaps security of this data? You want to ensure that at rest they are secured, in use they are secured, in transit they are secured. So there would always be a relationship between how do you maintain security for, especially when it comes to in use too. Because when you say, sorry, in transit, when you say data is in transit, it's actually moving through your network. So can I have security controls at the level of my network that can always cater for the security of my data, or probably I need to go ahead and also implement certain security for my data. My host, which is where the operation or probably use of some of these data are being maintained. Your server, your application, your compute, your containers. How do I ensure that they are secured? Then also my data itself, if I'm able to secure my security system, my storage system, my data itself being raw data, or private data in form of your databases, you would also look at that. Then also security of your application, it's also very important. Then now you have monitoring and governance. Governance is ensuring that if I've implemented security controls, number one, it's even what are my strategies for implementing some of these security controls? If I've implemented some of these security controls, how do I ensure that there are no drift? Drift will mean that over time there will be changes. So you can imagine that for my first use, when setting up a new tenant, I have a lot of configurations implemented. But over time, with operations, I have new administrators coming in, I have new changes coming in. Are there drift? Are there changes in my security baseline configuration? How can I ensure that even when with IT operations, daily operations, I still maintain that level of security? That's where we talk about governance. Then also monitoring. You operating an IT environment without having insights into what goes on is just like you walking blind, or what's it called, walking blind in an environment, or probably crossing the road blind. Because yes, you feel like you've done so much, but you don't have visibility into what's going on. So one of the key backbone of maintaining a very good security posture is you maintaining that visibility into things, how things are done. So here we're talking about logging, you talked about metrics, you talk about automation these days. You have a lot of automations coming around this particular space. So as things are done, and that speaks to the third part of when I mentioned the triple A, authentication, authorization, and accounting, or probably auditing, which is a core concept that is very important, that everything that goes on within your environment has to maintain an audit log or probably an audit trail, so that I'm able to monitor, so that I can pick intrusion, I can pick drift, or better still, I can go back to say, okay, this happened at so time, probably for forensic purposes. It's a very core aspect. And most on-premise organizations actually fail within this particular aspect. But when you use the cloud, it's one of those things that the cloud kind of give you by default, even though you may need to do more to make good use of it, or probably get best out of it. Most organizations will typically just set things up and don't look at this space. So this would also form a focus area for this session, apart from being even as a security administrator, is meant to be one of your primary focus area when you are looking at securing your cloud environment. Now, having said that, apart from maintaining your focus area, which we've seen here, it's also important that you are aware of baseline security principles for the cloud. I wouldn't even say for the cloud. This would also apply for on-premise environments. And when we say security principles, we are saying that when defining your security strategy, this should be one of those underlying principles that you have to put into consideration, because over time it's been identified that when this forms the basis for your strategy, uh, then it gives you room to maintain a very broad coverage of what needs to be done to maintain that level of security posture. So first is knowing what your assets are. If I don't know what I have, I would basically find it difficult to be able to secure. It's just like you having a room of over 1,000 doors and windows, which you don't know them all. Then how do you secure them? So even if I need to get a security guard for each of those doors and windows, if I don't know them all, then I won't be able to secure them all. Then, apart from identifying them, I should be able to classify them to say these are critical. My main doors, my main entries, or probably maybe I should put in the two guards, security guards, who carrying a machine gun. In some of the less critical doors and windows, I should have maybe just one guard with a pistol or probably with a machete or something like that. So I need to be able to classify and identify my asset. The next is the primary gateway for security, or probably number one principle for security, is maintaining authentication. Like I said, uh, when you CI triad, you have confidentiality. But if I don't know who is who, I'm not able to what's it called? Identify who is who or validate who is who, then I'm not able to secure. That is where authentication comes in. And within the cloud, it has to be strong authentication. Uh, Now, you may ask why. One of the key points of cloud, even though it might not be that all the time, is the fact that, oh, it's a public cloud and it's easily accessible. That's one of the points you'd always pitch. So, which means rather than you maintaining a local network where access to that network would require the intruder to have physical access to your office or perhaps infrastructure, in the cloud, it is a public cloud. So everybody can actually access M365. Everybody can log into Azure, basically. So your number one primary guard is to ensure that whoever is logging in to access your own tenant or probably your own resource or private resources is actually the right person. So you want to be able to authenticate and make sure that whatever type of authentication uh, you have chosen is uh, actually strong enough against any kind of compromise. Then the next is you want to maintain several level of security. Like I said earlier, there's no absolute security anywhere. What you are trying to do is make it you make it difficult, or probably you make it less worthy for an attacker to begin to invest in intruding your own system. So what that means is that if I have if I have, let's say, I have a gold of, say, $10,000, the market value of that gold is $10,000, and I have it kept somewhere, and for an attacker to come in, the attacker would have to do a lot and probably even begin to spend in terms of own resources, either his time, his energy, would be spending close to, say, $5,000, or probably even more than $5,000 to begin to make effort to get that particular goal. The attacker may typically just have a routine to say, why do I have to do this much just to get a $10,000 goal, which at the end of the day, if I have to steal it or probably sell it off, I would be at loss. So you make it difficult for them to do that, or probably you make it uh, 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 less the effort, you make it not worth the effort of doing it. So in order to achieve that, you typically want to maintain several levels of security. That is where you have defense intel. So which means uh, if I have the first layer, if you're able to break the first layer, you don't just gain access to my assets. You'll be faced with another challenge. You'd have to break that particular challenge before you come to the next one. So when the attacker begins to do that and feels like, is this never ending, then they could just have a routine to say, no, I wouldn't do this again. So you want to adopt that particular principle in also coming up with your security strategy. Then you also have the concept of least privilege. That means if I don't need it, then why should I have access to it? That is least privilege. Unlike within traditional system where uh, everybody gains access to the network. So you can imagine a traditional environment where maybe all devices are joined to the domain. All users are local administrators on their system or probably on resources where you need to grant permission to files and folders. You give everybody full control, and you have a web application that is accessible to everybody. Everybody's credential can log into the application. Maybe you have an ERP that is typically meant for a particular. The primary users of that particular application is just a subset of the organization, but the way it has been designed is that, on board everybody's credential, they can log in, they can access. So the challenge now is that those who typically need that particular resource may be conscious of how they use it, but for the person who does not need it may not be conscious, and maybe that would be the point of attack for an intruder, because number one, the person may not even know how to use that particular application. Number two, they may not even know they have access to that particular application. So there's nothing that is pushing them to say, let me do this cautiously. So, because they have all the privilege in there, even though they don't need it, they could abuse it. So that's the idea behind this privilege. So if you don't need it, then why do you need to have access? Then also adopt zero trust. Zero trust is pretty much a new concept within the security space, where it is saying that um, don't trust any system, any object, any resource within the environment. So within traditional system, we come back to zero trust. The idea is that once you're able to authenticate into the system, you are considered a trusted entity. Maybe a trusted user, a trusted computer, a trusted network device. So there's no restriction into what you can do. But these days, it's saying no, even when, because, so let's take, for instance, within the traditional system, you have a local network, and maybe it's not accessible publicly. So the idea is that your level of trust starts with any computer system that is able to be connected to my local network, because it means that the person would have to come to the office to connect to it. Then it's a trusted device. Then, so you would have an intruder that is able to break into your physical security and comes with a device and connects to your network, and boom, the person is trusted and has the same level of access as whoever even is the administrator within that particular network, and the it's compromised. So, but what zero trust is saying is that even if the person is able to gain access, still don't trust that device within the environment. Maintain some level of handshake to confirm that that particular device is actually meant to be trusted. So you'd also want to put that in consideration. Then the last I talked about monitoring and logging, very important, so that you have visibility within what goes on within that environment. Now, looking at some of these concepts, one after the other, to have a better view of what they look like. Uh, I tell within the traditional system, the question is always where are you coming from, or probably who are you primarily. So the idea is, I am internal to the network, and I've been able to authenticate as a domain user using that instance, using my domain username and my password. Uh, I'm joined to the domain, then I become a trusted device. Now, what that means is that your primary guard is based on location to say the person is a domain device and is joined to domain. Once you verify that, you consider that device to be secured and okay. But the challenge is that if an attacker is able to gain access that way, then it gives room for lateral movement. So, which means the attacker can just be connected to your network and begin to access all resources without you even knowing that I've got an intruder. So you could see instances of someone coming in and introducing a rogue JCP server, a rogue access point within your environment, and you wouldn't know. Users begin to connect to those rogue JCP servers to get an IP address and several other network informations, and they are being redirected to malicious resources. The same thing with the access point that would give out a malicious SSID, and users wouldn't know. You, even an administrator himself, could see the SSID broadcasted, connect to it, authenticate to it. The attacker is somewhere capturing some of those credentials, feeding it back into your system to gain full access to that particular environment. That's typically how this works within traditional environments. But when you are adopting zero trust, what zero trust is saying is that your focus of security shouldn't be your perimeter. Instead, your focus of security should be your resources and your data. So, which means that it doesn't really matter who is connected to my network. At the point of accessing resources or probably accessing my data, I want to validate that you are truly who you are and you should be trusted. And how can I validate that? I want to validate who you are, where are you connecting from, what level of security posture are you maintaining? Do you Have you exhibited some kind of abnormality in terms of behavior in recent times that I should be aware of? Take for instance, um, yesterday I logged in from let's say yesterday, say 10 p.m. I logged in from say Canada, and 10 p.m. yesterday I logged in from Canada. By 2 a.m. this morning I'm logging in from let's say Nigeria. Is that possible? That is typically not possible because the distance between Nigeria and Canada would, I believe, is maybe over, say, 15 hours or thereabout. So it's not possible for me to have moved from Canada to Nigeria within that short period. So even though you're a trusted person, even though that account truly exists, even though that account is meant to access that resource, I am saying that you have exhibited certain behaviors that will make me lose trust in you. So I shouldn't just allow you to access that particular resource. Or better still, yesterday your patch level, security patch level for your OS is, let's say, 2.5. And when I check, the latest security patch level is 2.8. Oh, you're not maintaining 2.8. I don't trust you again, even though I know who you are, but I don't trust you. So that is the idea behind zero trust, that you don't assume trust at every level. You'd have to go ahead to verify, to confirm that that person is truly who they are. That is number one. Then, in that particular circumstance, they can be trusted to access resources. When you go ahead to do this, then you kind of ward off a lot of some of those strategies that an attacker would use to maintain or probably gain access to your environment. And zero trust is actually a strategy, or probably it's more or less like a guideline or a principle that it doesn't really matter how you implement it, but you just have to implement it. Now, where it now makes where it gets interesting within the cloud environment is that some of these cloud providers would actually put up services features that are that makes it very easy for you to adopt and implement this strategy. While within the traditional system, you are left, you begin to nurse that headache of how do I make this possible? So I have to begin to buy this, buy that, buy security solutions, do this, do that. But within the cloud environment, it's not a matter of if the feature is there, it's a click, and you're good. So next, so I talked about zero trust, and some of the Microsoft zero trust principles include always verify explicitly and don't assume. So always validate all available data points, including the user identity and their location, the health of the device, the service or the workload context, the data classification. If there have been any anomaly, data classification could typically mean okay, this particular data is restricted for internal only, and I've verified this particular person. This person is valid, has been authenticated, but this person is external based on classification. So why would you request for access to this particular data? Then also always use least privilege. To come about that, least privilege would ensure that both data and productivity would be limited to whatever access they need. You have just-in-time access, just enough access, adaptive risk-based policies. These are some of the features you have within Azure that can help you implement zero trust. Then always assume that there would be a breach. So always assume that. So if you have that as a mindset to say, oh, uh, it's like these people would attack me or probably breach my system. So what can I do? What can I do? Oh, there's going to be a breach. What can I do? There's going to be a breach. What can I do? If I do this, there'll be a breach. So what can I do? So if you have that mindset, that helps you to build that in-depth defense, in-depth strategy to say, okay, for every point of a breach that you have identified, you'd want to put a control in place. And over time, you'd have layers and layers of securities that kind of strengthens your security posture. However, you also have to be mindful of the fact that most times there's always a clash between the level of security and usability. So, which means that if you maintain so much security control such that you make it difficult for your users to begin to consume your service, that is another challenge. Because what's the essence of a secure system that is not being used? So, you would always want to maintain a balance between how much control or probably how stiff your security controls are to how easy it is for your users to use them. Else, you'd end up seeing your users circumventing your system to just make it work themselves. For instance, you'd have before the idea of second factor authentication, you'd always have the idea of password strength always changing. First, it was 4 characters, 6 characters, 8 characters. In recent time, I was seeing somewhere where they said 14 characters of password. And in some critical system, they will say maintain a very long password. But you can imagine if you have a password that is 14 character and above long. For a password, you need to type almost every day or probably every now and then, and you have several passwords that you need to remember. What will prevent you from writing down that password? So that is why for most people that would carry out physical penetration tests within the environment and begin to do some kind of social engineering tests. When you go to a physical location or an office to carry out such tests, one of those things you want to begin to look out for is look out for sticky notes around systems or probably chewing gum under the decks with a paper attached to it. Typically, what you'll be seeing there is someone writing down a password, or probably on the decks, someone writing down a password so that they can always remember. Or probably you have the sticky note feature on Windows where you blow it up and check someone has a password. That is because the system has been made so difficult for them to use that long password, and nobody wants to remember that password. They write it down, and when they write it down, or probably stick them somewhere, then someone else could be watching, someone else could see it and make use of it. So you have to maintain a balance. Then I'd mentioned the idea of defense in depth. The idea behind defense in depth is that make it difficult for them to get through. So you don't just maintain one layer of control. You would want to maintain several layers of control. For instance, within the Microsoft environment, you could have controls for identity and access. You'd have controls like rule-based access. You have multi-factor authentication, centralized identity management system, identity protection, privileged identity management. you have multi-factor authentication, risk-based identity protection. You have a whole lot of them that when you pile them up, then it's not as if it would make it entirely difficult. It would make it entirely impossible. It just means that it will make it very difficult and it will give you better visibility even when you're under attack. The same thing applies to application and data security. You could do encryption, confidential computing, management of keys, management of certificates, information protection. Likewise, network security, you want to enable your DDoS protection when you DDoS is actually an attack against availability that makes it impossible for users to access your resources and use them. So you want to enable that at the network security level, implement a firewall, web application firewall, use private networks, use network segmentation. That means don't just bundle all your resources into one broad network. You want to segment them based on classification of what should go into which network. At the threat protection level, you also want to use anti-malware, antivirus, AI-based protection. You have a lot of cloud-based protection services within the Microsoft Defender for cloud. You have the CASB. You also have Microsoft Defender for SQL, where you are able to begin to identify when someone is intruding into your SQL services or probably even taking advantage of any security vulnerability that may exist within SQL. You also have a number of security controls for your IoT. Now, when it comes to security management, I'd emphasize this. That is where you talk about gaining visibility into what happens, and you can always do that by maintaining logs and metrics, doing carrying out assessment, having governance policies in place. Where governance policies are policies you put in place to say all the time, I want this to be this way. For instance, I don't want any administrator to go and spin up a compute VM in, let's say, the US region for whatever reason. Maybe I'm looking at complying with data location regulatory requirements, if there's any that says don't maintain data in the US, or probably don't maintain data in the China, or probably don't maintain data in the US sub-region. So which means under no situation, even though even if the cost of compute would be cheaper if I spin it up in that location, I'm saying that because I want to comply with this particular regulatory requirement, I don't want administrators to go ahead and spin up services in there, because some services can be location based. But however, it's easy for me to just say it and tell it to the administrator. But being human, we may forget. So I want to put controls in place that would enforce that. So I would put policies in place such that if I had an administrator going and selecting a compute and the region is saying maybe US or US Central, probably US West, it will tell you that no, you are not able to spin up a service in there, or probably you wouldn't even see that particular location available to you. Then the next thing is actually maintaining a security incident event management system, which is the standard for maintaining visibility. So typically what the SIM would do is aggregate logs, some of these logs and metrics within a location, so that you would have a central view and begin to operate like a SOC, which is a security operation center, where you have individuals dedicated for analyzing, reviewing some of these logs. So begin to identify any patterns, any trends that may suggest that any of my security controls are being breached. So, and the idea these days, you see, the traditional way of security before now is that I just throw security solutions at my infrastructure. Oh, there's a firewall, I get it. There's a network detection system, I get it. Host detection system, I get it. Honeypot, I get it. Vulnerability management, automated vulnerability management and scanner, I get it, and I implement them, and I sit back. I've got enough security controls in place. I've spent so much on security. Then I sit back and believe that I'm secured. However, the approach to security these days is that uh, okay, yeah, I got that. So would even though we don't, let me see how much we have. This is 1 hour. Oh, okay, yeah. So we could just do 5 minute break after this, or probably 10 minute breaks, which makes a lot of sense. So these days the approach would be that you go and begin to look for indicator of compromise yourself. You don't just sit back and believe that, oh, all is well. These days you'd begin to hunt for what may look like someone is intruding you. So it's just okay. That's not a very good example. I typically want to use an example, but but it's just like you just believing that you've got all locks and keys, the most sophisticated locks, keys, you have CCTV cameras in there and thereabout, but you still get a private detector. And what the private detector will do is begin to move around and begin to sniff around to begin to look for situations where people may be discussing about intruding your system, or probably people have been intruded and try to understand how they were intruded, and you learn that and you come back home to begin to make your own system more secure. That is the approach. So you begin to talk about concept about something like trend hunting this time around, or probably cybersecurity intelligence. You gather intelligence of what are the trends you hunt within your environment, and you use that to maintain a better security posture within your environment. Yeah, so would go for say a 10-minute break. Within that period, if you have questions, you could typically just drop them within the chat, and we'll take those questions before we continue. So we'll come back in, let's say, so let's say 11:25 or 11:26. So, like I said, if you have questions, you can just drop them, and we'll take them when we come back 11:26. hope we are all back. Okay, good. So, before we left, we were talking about defense in depth and making it difficult for the attackers. And we have just run through a number of those things that can be done in order to achieve defense in depth within the Azure environment. So just give me a few seconds. So next we'll look at some of those security features or private services that we have within Azure, and we'll just quickly run through this of Microsoft documentation. So, like I said, for most of the cloud service providers, you have services that would typically come with baseline security features or perhaps security controls, but they may not be enough to give you that level of security posture that you desire. So there would be additional security services, a large number of them premium, which means you'd have to pay for them. That if you want to be able to use these to maintain a higher level of security control, you would have to pay for them. So they are part of the security service catalog, and you have them in classified based on what is the target. That is, what is the target service or target asset that is being secured. For instance, you have a general Azure security. Under here, you're looking at the Microsoft Defender for Cloud, which helps you to protect your workload. So, Microsoft Defender is actually a suite of a security product for different target use cases. You have Microsoft Defender for Identity, Microsoft Defender for Cloud, Microsoft Defender for IoT, and the like. Then you have the Microsoft Sentinel, which is a SIEM. We saw that in that defense in depth, that SIEM typically gives you insight and it helps you with threat intelligence and also threat hunting. You have the Azure Key Vault, you have the log monitor, you also have the dev and the test labs, which allows you to just create a test environment for your services. For storage security, you look at the storage service encryption, Azure Store Simple, client-side encryption, Azure shared storage signature for granting access to your storage account, storage account keys, Azure file shares, storage analytics. File shares is actually what works like your typical shared folder within your environment where you're able to define who have access to certain shared folder or not. We also have a number of security services or features for database, SQL firewall, SQL encryption, SQL always encrypted, transparent data encryption, auditing. You would also define network rules for your SQL instances that restrict what is able to connect to your SQL database or not. Even though identity and access is a security on its own, you will have additional services that can help you maintain high level of security control within that. Like you have the role-based access control, which we're talking about. Your Azure Active Directory is your primary identity and access management system within that environment. You have several other Active Directory services, like the Active Directory domain services. It's different from the Active Directory services. You also have the business to consumer for Active Directory. You have the multi-factor authentication, which a number of us may be aware of. Backup and data recovery. You have the Azure backup, site recovery. Then you have for networking, network security group. You can spin them up your VPN gateway if you need to extend your on-premise network to your cloud network, your application gateway, your web application firewall, load balancer. We talked about load balancer, web application firewall. We did talk about it in the first session which we ran for the Azure administration. You also have express route, traffic manager, application proxy, firewall, DDoS protection, private link, service endpoint, front door. You also have Bastion host. A number of these would discuss in more in depth when we begin to run through the course. So this is a very good point of call for you when you are looking at what are those security services that I can deploy to further maintain certain level of security for each of the services that you may be working with within Azure. You can just click on them to understand how they work much better. So now coming back to the slide. So now let's go and talk about the network architecture I've made mention. Now, within a traditional system, you'd always have what referred to as creating network architectures based on zones. So what typically that means is that I want to segment my network, identify what would be my internal or trusted network. I'll identify what would be on my DMZ and identify what would be in more restricted networks so that when you have external users accessing my network, which part of my network should they have access to? When I have internal users, which part of my network should they have access to? Then some restricted part of my network also, what should they have access to? That is what you do in a traditional environment. Now, within a cloud environment, also, you may want to be able to maintain that level or probably that type of architecture such that when you have an external connectivity coming in, there's just one part of your network which they can hit, and probably they can't go beyond that, depending on what they want to access. So that is why Microsoft has put up, even though there are different types of network architecture you may want to maintain, but what Microsoft typically recommend is you always maintain a hub and spoke type of network architecture, which is what you have within this architectural diagram. So what does that mean? So it means that you would have different network segments, but you'd have one central network segment. I believe we discussed it in the last session we ran, where that central network segment is called your hub network. And what does your hub network do? Your hub network would connect to every other part of the subnetwork you have, including the external. Now, that connectivity now allows you to be able to segment and restrict what can access what. Now, within Azure, you can have different network which you typically call VNet, and each of those VNets are a separate network on their own. So if I have several VNets, which you can liken to subnets within a conventional or probably traditional environment, a different subnet. Within a different subnet, if we still remember our networking, different subnets would not be able to communicate with themselves except you'd make that happen. Maybe you do your routing, that means you'll be placing a router between them to say network from this part to another part should be routable, they should be reachable. That helps you with your network segmentation. Within Azure, it is called peering. So if I pair one VNet with another VNet, it means that both can actually cross connect or probably cross communicate. So since I have that feature, It can help me identify what sub-network should be accessible from the hub network. And in addition to being a several network, that hub network will be the concentration of majority of my security control. So which means it is the gateway into my internal network. So I want to have a firewall, I want to have a VPN gateway, I want to have a network security control, I want to begin to monitor what goes into and out of my network. All would reside within the hub network. So at the level of the hub network, I'm able to begin to now define different security controls or perhaps different protection for different part of my network. Now, this forms part of what you may, especially when you are just spinning up your Azure environment for a start, because a large number of time, if you had already just defined your Azure tenant without a strategy and it's already running, that means it's a production environment. It's difficult for you to begin to retrofit that into some of these strategies. So it's always something good that you plan before you go ahead to do that. So when you are designing what will be your security strategy, you want to put that into consideration to say, how do I ensure that I have an optimized network architecture that helps me minimize costs, optimize efficiency, and also give me that level of security. Reason being that it's possible for me to have just one Azure firewall at this particular level that begins to control or probably restrict access to different part of the network. Unlike if I don't do this and I begin to maintain different network in silos, when I begin to do that, then it becomes difficult. Then in that particular case, that's when you begin to see people slamming technology on their design, trying to make it work. So I have to begin to now have firewall on each of my network as what's it called? It demands, when it is very possible for me to just have one at the hub network, which feeds into several other networks. The same thing applies to VPN. And one of your use cases of VPN would typically be you want to be able to still connect, especially when you run an hybrid environment, you want to be able to still connect your Azure network to your on-premise network so that you can still access resources and restrict any external access. Now, the way this would make sense, especially when it comes to cloud computing, because a number of people would struggle to understand, is just think of the cloud as your IT services and infrastructures in someone else's location or probably in someone else's office. And that is just simply put how it works. All this is within Microsoft data center in any of the locations. And the same way you would operate it if they were in your own location is how you want to operate it within the Microsoft environment, except that there are a number of things that, when you look at the shared responsibility model, a number of things that the service provider would be doing on your behalf. But when it comes to you maintaining connectivity, traffic flow, connections, you want to look at that in that perspective. So, which means that the only way I can do this is either to do a VPN, although you could have another way, which is using express route. For instance, if taking an on-premise instance, if I have an office, let's say in Lagos, I have another office in Abuja, I could do a VPN, or I make use of a service provider who would have a direct link between Lagos and Abuja, and they give me a list line which I can use to connect both offices. In some instances, in those days, you would always use a VSAT, which will connect both offices. That's the same way this works. If you're not using a VPN, you could use Express Route, where Express Route is being offered by serving certain large service provider that maintains backbone infrastructure together with Microsoft. Very good example is one here in this part of the world. You could use that to connect your physical infrastructure to Azure, but that will still go through the hub network so that you can centralize all your security controls within that network. So which means whoever needs to gain access, for instance, to my production spoke virtual network will first of all have to breach all controls that I have at the hub network. I may not have as much security controls as I have on the hub network, on the spoke network, because I know that I am centralizing and concentrating all my controls within that particular hub network. So it's just a recommended architecture, not what's it called, not a gospel truth as the case may be, which means that if you have better architecture based on your design or probably your requirements, you may want to go with that. Now, let's talk about where your responsibility lies as a security engineer taking this course or probably going through some of these lessons. Uh, as a network security engineer, primarily, you'll be responsible for implementing security controls and maintaining the organization's security posture. So you'll be managing identity and access, you'll be protecting data, you'll be managing applications, you'll be managing network. Uh, Mind you, this is meant to be a specialization, so which means that you'd be expected to typically focus on this. But like I said, that depends on what is the organization you work for, what is their approach, or probably their hierarchy, or probably their workforce kind of thing. So, which means that you may be responsible for the administration bit, and may also be responsible for security bit. But as the security administrator, you would want to know as much as what are those services and how they work for you to be able to to secure them. Because if you don't know so much about something, I doubt if you're able to secure that. Then also you be responsible for identifying and remediating vulnerabilities. Also, you'll be responsible to incidents, responding to incidents and escalation. Incidents are occurrence of anything that might have breached your security controls. And what makes it easy for you to be identified that there has been incidents and for you to do what you need to do is when you do proper monitoring and log management, and maybe you have a SIM in place. And that is always the challenge for most breach. A large number of times, there's this statistic that most times that most breach will take up to like maybe 65 days after they might have occurred before you get to know. And the reason why that would happen is if you don't have enough or probably adequate or in-depth visibility into your environment. So which means someone had intruded into your environment, have been within your environment, moving across, pivoting from one system to the other, exfiltrating data, modifying and intruding with the integrity of your system for over 45 days before you get to know. If you go and check most of the breaches you have out there that are made public, large number of them would have happened long before the organization tend to know. And when you begin to check, well, like I said, there's no perfect system anywhere, but which means they lack visibility for them to know. It is the responsibility of security administrator to begin to look around to ensure they capture enough indicator of compromise. What are those things that I can see that may give me an idea that, wow, I may have been breached and I need to begin to do things to carry out remediation or probably respond to that particular situation. Then you may be working as part of a large team that is dedicated to the cloud, and your responsibility within that particular environment is to secure the cloud environment or probably even to secure an hybrid environment. So then also you may want to be familiar with scripting automation and have a deep understanding of networking and virtualization. The reason being that, like I said earlier, what you don't know about, you can't actually secure. And that put that out also that the basic requirement would be that you have basic understanding of networking, have basic understanding of systems, you have basic understanding of security, and that will put you in a very good place into joining into a full stack, if I can use that word, cloud security engineer. So that's let's stop here for today. And if you have questions, let's take the next 15 minutes to ask questions so that in the next lesson, which would be next week, we'll be moving on to talk about the first aspect of this lesson, which is identity management, and try to dive deep into it. And I believe that by that time, we would have, if we don't have one yet, or probably have not signed up for the Azure security, for the Azure subscription yet, it's a good time for us to do that. To that to sign up with a card, although you will not be charged. If you still remember how you did that of the last session, yeah, it's still just the same way. Most likely, the one you opened for the last session would have expired. I'm not sure, but you may want to check if that you used in the last session is not expired. So all you just need to do is to sign up with a different, probably a different card and a different email address, and you'd have another free trial subscription. So if you have questions, let's attend to them in the next 15 minutes. Okay, someone had asked earlier that is this session recorded? Yes, it is recorded, and you would always have access to it. Okay, if there are no questions, would call it a day here. And if at all after the session you have question, you can drop it uh, in the Discord channel, or probably you can send an email. If you drop in the Discord channel, uh, oh yes, oh sorry, patience. Yes, yes, yes. Came back about that should be about 20 minutes ago, thereabout. But you can always the session is recorded, and you can always just go through it. So I was just asking if you have questions. If there are no questions, or probably if you have questions after the session, you can always drop them in the Discord channel, or better still, you could drop an email. Uh, then also, what I would typically do is, like I said, this is a self-paced learning. It's always good that we go out of our way to still do some learnings on our own to really drive on some of these concepts, and also practice. Practice, they say, makes perfect. So I would share a number of resources at the end of each lessons, where we can go for maybe concept I feel like we should know about, or perhaps concept I want us to deep dive into. You could go through them. If you have questions, you share them, or probably drop them. I would always encourage that you do that within the Discord channel, so that while you are learning, you are also encouraging others to also learn. And if you hope to sit for a certification at the end of the lesson, you may also just let me know. Then I can also help you, provide you with some additional resources where you can dig deeper and just take the certification. So next week, we'll be back the same time, and see you then. Bye.